Yo. Hello. It's 11:19 p.m. Central Time on the 8th. Is it? It's still the 8th? Yeah, it's the 8th. And hope you're doing well Saturday night. Of course, we do have a few earthquakes that have struck since doing my last little update, guys. Turkey got hit right here in the middle, up and around the bend of the plate. The middle between here and here. If we go up and around the bend back down to there, the rough halfway point right here, right next to the halfway point, our new earthquake struck. It's a 4 to 4.3. Sound familiar? How about a 4 to 4.2 on the west side, and a 4.3 to 4.4 on the east side, and a 4.3 to 4.4 on the south side? Again, we're looking at everything 4.0 and greater, so you can see it. Same sized wave spreading out across all sides of the plate boundary. It's going to be coming back together here over at South Italy, where I had my warning going last week and nothing hit. Strikeout last week, South Italy. It's been over 7 days. There are spots where they get missed. It's just like hurricane forecasting. You can get an area where you're looking, and then instead it'll go around the area that you're looking, basically. We have not seen the earthquake strike yet, so it's been like 9 days. I warned for 7, and it's been 2 days beyond. I'm trying to get it down to a 7-day time period. So, I mean, if the earthquake hits tomorrow, I mean, you know, that's the earthquake we're looking for. It's just took 2 days longer than I was looking. Or I was 2 days ahead of time. I was premature in issuing a 7-day warning. Maybe I should have issued a 10-day warning. Anyway, it's just me on my own. I have to set my own rules, so just kind of trying to get an area down in a time frame of about a week to watch is what we try to do. You can see the spread going over to Europe now. Again, it's all stuck right here. I was looking for it to go right over to here and break here with a significant sized earthquake. Upper 5, low 6, somewhere in that range, maybe even bigger, right here out in the ocean. And it didn't hit. And instead, we got a reflection back and forth through here, which is what we're seeing now in the last 3 days, 2 to 3 days. Here's 3 days. Here's 4 days. So you can see it went over to Europe, went out to the mid-Atlantic ridge. Those are the red-colored earthquakes. That's the last stepping stone path that we have going out over the past few days. Meanwhile, it's all stuck right here. And again, this is 4 days worth of quakes. Can you tell where the wave is stuck between? It's like bookends, right? Going in from one side, spreading across, going to the other, and it's bouncing back and forth in there. So we may, again, if I'm looking for a large earthquake to hit here, and we don't get it, and then we get into the next week, and it's bouncing around like this in here, maybe I need to reassess where we are, cancel the warning entirely for Italy, and reissue it just smack in the middle of this. It's a tough decision to make, to cancel a warning for one location and issue it for the other, without an explanation as to why we didn't get our break at the end like I was looking for. If I get an area wrong, I don't reissue the warning. Again, I'm not like trying to get people to watch or anything. Like I've got many viewers, for instance, over here in South Turkmenistan or something. I mean, there's nobody ever even gets my warnings when I issue them. They get them after the fact and say, "What? You issued a warning day before too?" Something like that, and I'll be like, "Yeah." They're like, "Why didn't we get it?" I'm like, "Well, I'm talking in English, and good luck trying to get information shared from YouTube or on social media for that matter. I mean, you have to know somebody to even get information these days, right?" Okay, what else is going on? Not much. So we're jamming music. Just wanted to jump on and say hi to you, let you know I am here. We do have some stuff going on weather-wise that maybe I would want to show you. So let's turn on a display capture really quick. Just really quick. We're not doing a big weather update or anything, guys, but I do want to show you what's happening. So if you're here in the States, this is the infrared view. Obviously, 2 spots are blowing up. One right now, current blowing up out over Kansas, the other over South Missouri. I'm going to turn on the radar. And we got a big old outbreak taking place across Kansas right now. It just flared up. But we're going to go back through the start of the day and just watch what blew through. Let me show you where my location is. Just if you're looking at the screen and you can see this, it's pretty small, but my mouse is right here. Okay, that's my location, just at west of St. Louis, Missouri, just so we know where I'm at. So what I got to see today was that blew over first, and then throughout the day it was actually really nice. Got a little cloudy, and then we got our severe outbreak right there. Okay, it just blew up south of St. Louis. We got flashes of lightning in the distance, but I got no or light rain here. That's it. But Look what's breaking out back across Kansas right now. Do you see that? Pretty wild, right? Let's go take a closer look at this so you can see an up-close view in Missouri. And we'll look at the radar, too. The actual NEXRAD radar. So here we go. Again, that blue and swirled right across our location where I'm at throughout the day today. And then, boom, this is the outbreak as it took place across Missouri right here. So just south of my location. I want to go look at the NEXRADs, and I want to go look at each individual station really quick. Again, it's only going to take a few minutes. It's not going to take very long. But we're going to start to point out things about the spacing on the storms, for instance, like down here in Texas over Amarillo. See this? Boom, 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 boom. See the spacing on that? The non-natural spacing on the storms that as they break out. You also talk about the beams over South Carolina, North Carolina, beaming up over the border region. But let's go look at the NEXRADs. Okay, we're going into, I guess, we'll go to St. Louis first. And I don't know why we're going real slow all of a sudden, but we're going real slow. Let me close all my other windows, just make sure nothing else is running. Okay. There we go. All right. And we're going to look at 200 images. Yeah, I don't know why my internet would suddenly slow down. Look at this. Storms are way out of here. My location, right here on the red line, west of the black dot. The black dot is the radar at the center. We're going to watch the storm blow through today out of St. Louis. And then look at the 50 to 100 nautical mile range. See this? See this right here? The spacing on the storms, if you follow these back, these are curved, and these go back towards the transmitter, which is rotating like a pinwheel. These are actual storms that are forming, though, along the field lines of the radar, from the 50 to 100 nautical mile range. See how it paints across there like that? That's the beam painting. Looking at the storm out to the east, it's causing more storms back behind it. And that's not a reflection back, guys. There's storm totals on that if you want to see it. Again, that's not natural spacing. Each one curves and curls back to the transmitter like this, like a rotating pinwheel. Okay, let's go through it throughout the day. What happens out west? At the 100 nautical mile range, boom, we vaporize at the 50. Literally, when it hits the 50, it's coming in, storms, quote unquote. Look at the spacing on those. Same thing, it's doing the pinwheel shape, but in the opposite direction. So one side they're going this way, the other side they're going this way. As it comes in, vaporizes at the 50, poof, gone. Throughout the rest of the day, we get more forming. Now watch this. Forming in beams going right back to the transmitter. This comes out, goes out, up. That's not a boundary, guys. That's actually from the radar. And you'll see it form at the 100 and at the 50. Go around the 50, and that's where we are now. So it just missed me. This is where we saw some flashes of lightning. And let's trace that back where that forms. Watch. It forms exactly, boom, right on the 50. Spreads out along the line. Goes down and around the 50 nautical mile range. This is in St. Louis. Okay. Now we're going to go down to southwest Missouri. We're going to look at what happened down in Springfield. Haven't looked at this. It's a play-by-play as I'm looking at it live. I'm play-by-playing the radar for you. It's almost like sports. Watching live play-by-play weather modification of the weather. Using the radar that we also use to observe the weather. So let's see what happens. First of all, spacing on the storms. Look at it. 1, 2, 3, 4. And they're curved again, going back in that shape back to the transmitter. Let's look at the storm totals to prove that to you, that there's actual rainfall tied with this. Man, you'd think I was on like a modem or something. Literally, we were cruising. All of a sudden, tick-tock. Okay, there we go. Right there, right. See? 1, 2, 3, 4. And we're talking about the difference between light blue and dark blue. So 1/10 of an inch of rain to near 1/4 of an inch of rain. And then 1 hour storm total, show it. Okay, I just wanted to show that to you. Again, the 1 hour actual rainfall precipitation shows it. Let's go back and look again. So this is where we start. Start of the frame right here. The 4 storms. 1, 2, 3, 4. Actually, 5. Go out. Then more form along those lines. Watch. Down here, each one. So, wait. Okay, see the beam painting, and it's forming the storms along where the beam is painting. It happens up on the north. 100 nautical mile range, exactly. Right there at the 100 on the north side. We flare up. Storm formation. Little lines going back towards the transmitter as it moves through, and then it curls in and goes back to the transmitter. And 1 hour storm total. We already looked at it. You guys saw it. Okay, now watch. This play-by-play. I haven't looked at this right. So 100 nautical mile. We flare up out to the west-northwest. Equidistant space storms, 4 of them. Then, watch. Right at the 50 nautical mile range, we explode. And the spacing. Let's count it. Got 4 to 5 again. In a row. Going back to the transmitter right here. 1, 2, 3, 4, 5. In the field lines along the radar. The storms are propagating along the field lines of the radar, guys. The horizontal planes, scan lines of the radar are actually forming storms. Goes right over the transmitter, forms around the 50, out to the 50, and this takes us up to current where the beam is painting to the west, and this is our most current image right here. There's all severe weather forming right now. We can see way out beyond the 100 nautical mile range, by the way. The radar, when they pulse it, goes out about 300 miles. Let's go look at Kansas. Let's watch this sucker form across Dodge City, Kansas. Get out of Dodge, right? Well, this is where the next rad radar is. Let's go see what happens across it. Take it back to the start of the frame. Haven't looked at this, so I don't know what's going to happen. But I got a feeling it's going to be like all the others. Okay, first of all, storm formation. Equidistantly spaced. Apart, down to the south, out beyond the 100. And... wow, okay. So inside the storm itself, you can see it. The equidistant spacing on the storms as they're rippling back and curling back towards the transmitter. But let's just go in and watch some more. Okay, there's a lot going on here. We're going to look at the southwest side first, then we're going to look at the northwest side. Southwest side. It branches straight into the 50 nautical mile range right here and goes into the inner ring right there. Let's watch that happen. Storm formation right here, exactly at the 50. Boom. At the 50, 50, 50. The storm to the south breaks at the 50 and goes in a curved line like this, up this way around the edge to the east-northeast. Let's go back and look at the other storm to the northwest coming in. Okay, same thing going on. As the storm's coming in, they're looking at it. As they're looking at it with high-power microwave, it's actually generating more storms coming back. That's not an echo. Storm totals should show it, spreading towards the radar. First, as the beam is leading it, basically, or creating precipitation out in front of it, scuffing its feet across the carpet while they're looking at the storm. They're scuffing the feet across the carpet with the radio waves, if you want to think of it like that. Wow, we're not loading it all now. I've just been cut. Stuck at 100%. All right, you know, it is what it is. Stuck at 100%, right? Let's hit refresh, just make sure it's not in error. Oh, now it loads. Well, these are the storm totals. Look at the spacing on the storm totals. 1, 2, 3, 4, 5, 6, 7, 8. Equidistantly spaced. And we're going up to 3 inches at the center of some of these. Jeez. The storm totals tell it, man. Again, you don't have to just say it's some radar return weird image. Look at it. Let's go back and watch. Oh, God, no wonder they're like, should we show it? Who's they, right? Okay. Boom. Right here. So you can see it again. Now we're going right across the center of the transmitter from one side of the 50 nautical mile range to the other. There's a big amount of energy. Here's the scan lines of the radar back behind it, the blue and the yellow and the blue. You'll see the storms are forming along those lines. The spacing tells it, guys. It's on one side and on the other of the transmitter. Look at it. Up, 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 up. Going back over to the 50 nautical mile range. Let's go back and watch and see what happens. Comes in, explodes at the 50. Look, beam connects right there. Beam connects between, they're looking in, boom, 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 goes right into the center of the storm. and at the 50 nautical mile range. You got to remember, we're looking down on this. Look at this three-dimensionally. They're shooting up from the ground, up, up, up into the top of the storm to look at it. And these lines here, that's not an echo. There's storm total on those. Okay, now, watch. Explodes. Goes from next to nothing, which is the beam looking, explodes along the field line, and curves back towards the center of the transmitter. Got to remember, this is rotating the transmitter. And then the storm explodes from next to nothing right there. See, it's just some red, and there's a little pink core back here. See that little pink core? Now watch what happens when it gets into the 50. Doosh! Explodes on both, well, like it's hitting a force field. Let's watch it close. Right there, explodes into bright blue and white. There, and then on the other side. Equidistantly spaced on both sides of the 50. Perfectly. Then, as soon as it gets past the 50, it flares back down like it's penetrated through the barrier of the 50 nautical mile range of the transmitter, the high power microwave. As it comes in, boom, passes right across, evens out, spreads out into these 1, 2. We're looking almost like an echo top. Let's go look at the echo tops. I'll show you. So it almost looks like an echo top, but this is the actual storm formations. See? Long-time radar viewers will know what I'm talking about with echo top. On this side, too. Equidistantly spaced as it comes into the transmitter, breaks, hits around, goes around, spreads out the other side, flies out the other way. Now, see this? See this sawtooth-like shape that goes out to beyond the 100? See that? 1, 2, 3, 4, 5. This is actual echo tops now. We're going to go look at total storm totals on this. And if that matches, the radar itself, the pinwheel-like shape of the radar, is producing the storm. So, basically, simply put, if the precipitation matches, which it does, look, it's going out along the spoke lines of the radar. Let's go back, though, and watch. Right. Oh, they're cutting it every hour, but boom. Even with them cutting it every hour, you can see it. You should be able to see it. Here, we can watch it fast. This is on storm total now. So it matches. You can't tell me it's a echo or a glitch or something because there's actual storm total on this. All right, so this is Dodge City, Kansas. It's blowing up across Dodge City right now, and this huge line of storms is spreading out this way in between both radars over to the east. So it should be symmetrically between both radars. I'm just calling it right now. I haven't looked. It's live. So hopefully you guys can see all this. So let's go see. Does it go between both radars perfectly? First, look, at the exact 50. Now watch. See the other radar on the north side, this little white dot? It's going between these two. These are the two radar stations. So should it overlap on the 50 on the other one too? What do you want to bet? They both overlap on the 50 and that's where the storm is. Bet one person $5. Yep, it's on the 50 down to the south. Look at that. So, forms on the 50 to the south. Or hits the 50, goes into the 50 from the 100 to the 50 there. And that's Topeka, Kansas. And now we're going down to Wichita, Kansas, and there it is on the north side. Hitting the 50 there. Right there. Now, you can see it starting to take here. 1, 2, 3, 4, 5, 6. See this? See the spacing on this? These are the spokes, quote-unquote, of the radar as it's looking and turning, and it's actually making the shapes of the storms, and the storm total reflects those shapes, which means the radar is making the weather in those shapes. Watch. One, 2, 3, 4, 5, 6, and then see these? 7, 8. See how they're all curved like that? Okay, 1/10 of an inch of rain on those, and that brings us up to current here. On the outer bands, and the inner bands are doing, what, 1 inch of rain? 1, 2, 3, 4, 5, as it's coming in. Spreading across to the 50 exactly. Okay, so the curved spokes of the radar are matching the actual precipitation, which means that the precipitation is falling in the shapes of the field lines of the radar, which means that the radar is influencing the weather. So you get 4 huge cells to break out. 1, 2, 3, 4, 5, and they're curling back towards the center of the transmitter. You got to understand this curls as it's looking up, spinning, and curling. It's like a pinwheel spinning, basically. Anyway, this is Kansas right now. Boom. So what's going on up to the north? Same thing. Field lines of the radar, you can even see it. Literally. Boom, 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 boom. Looks like a vortex. And the storm formation inside of the storm formation. So 1, 2, 3, 4 inside of the greater 1, 2, 3, 4. Which themselves are all made up of smaller storms that are breaking out in weird field lines around the transmitter. This is Wichita, Kansas now. Now let's go look at Kansas City, see what it shows. This is all the NEXRADs around the world do this. All right, now we're looking at Springfield, okay? So we're back to, we're looking at Kansas City. So I haven't looked at Kansas City, but it's doing the same thing. It's doing the exact same thing, the spacing and everything. And if we go check the storm totals, it'll match, I guarantee it. I'm tired of trying to prove that. Like, it just takes too much time to keep up with storm totals. So you guys can go look at the storm total precipitation. Looks like they cut it, hold on, right here. They cut it from 2146 for an hour and a half. Are you serious? Wait. No, 12 hours. They cut it for 12 hours. Look at that. 13 hours. It's off. So from here, boom, storms are coming in to the 100 nautical mile range right there, and it looks like they're doing something. Oh, wait. Oh, they cut it right when this starts to happen. Look, hold on. Comes in, starts to form, and then boop, off for 13 hours. Literally, it's like going over a fence. Think of it like that, like somebody hurdling a fence. It's like a bubble going back to the transmitter. Okay, so they cut it, boom, off, and then it comes back and we're down here. All right. So let's watch it forward from here. The last few hours. It's still showing it. Okay, so we have the equidistant spacing on the storms again, going out across, going in a line back. The curls back to the transmitter. It's a hard curl that's going to go back in. Like a hurricane. When they show a hurricane symbol. Or another way to see it be on the base velocity also shows the curvature that I'm talking about. The dead zone, or the zero zone, the white zone, in the middle always shows it. See that? The white comes in, curls, and goes back down. Now this rotates. Okay. We can see it on relative mean velocity. The curvature I'm talking about now. The curvature. That's all. The only reason I'm showing this to you is to show you the curvature of the beam that I'm talking about, that the storms are forming along. Man, this is taking forever to load. Either there's a lot of people watching or something. So they're flipping polarity towards and away from the radar. Red is away from the radar. Green is towards the radar. White is the kind of in-between zero zone. Wow. Pretty interesting that it gets like that, and then they flip polarities, and it gets wah. Could add sound effects. Pew! Pew! Okay, so there's a large amount of radio wave power in here, guys. 700,000 watts. Now see that right there? How that flares up to 90 knots blue on one side, and it's conversely going bright red on the other, up towards almost yellow. Let's see if it goes yellow. Does it go yellow? No. So what's going on there, right? We got a huge velocity signature of a huge burst of wind to the east side. What's going on? Let's go look at the radar and see what happens around that time. Not much showing there at all, is there? Okay. Are you curious? Let's go see what's going on the differential. This is all going to... oh. TikTok, we'll wait for Grandma to dial in on our modem. We got out my fax machine. Got to fax the National Weather Service. They're going to send me back the data. Get my flashcards out. Well, not showing much there either. See, this is what's problem when they shut the frickin' radars off at sites, guys. I'm skeptical. I'm really skeptical when I see a radar shut off now. Used to be once in a blue moon. Now it's happening every week. Come on, man. Come on. Come on. Whole networks go down for weeks on end. What's going on? We're going back down to southwest Kansas, go and look at Dodge City one more time, and then we're going to go back and look at the composite. So, radar weather modification. Can it be done? Is it possible to modify the weather with radio waves? The government says yes. On the NOAA site, it clearly says it. Number 8 on the list, electromagnetic radiation, which is radio waves. Number 8 on the list, possible. And then we have all the writings from Lieutenant Colonel Thomas Bearden, of course, talking about particle use of radar as a multi-purpose battlefield weapon. Not just for observing things, but for removing energy and mass out of a location, pumping a location up with energy, melting things, making cold explosions, making hot explosions, crossing beams, time reverse scalar waves, not time travel, but like reverse on timing on the waves where you cross it. You get gravity waves that come out of a time reversed wave scalar area. That's Lieutenant Colonel Thomas Bearden talking about all that. And then we have all the examples. So storm after storm hitting at the 50, 100 nautical mile range and then exploding over the transmitter and spreading out across to the next transmitter. Playing a game of hot potato where they're passing it between stations at the 50 nautical mile range. Zapping things off, zapping it up. Now, what do you want to bet if we come down here to the east-southeast? I want you to look at this three-dimensionally. We're looking down on the radar, and this is beaming up like a spotlight from a furniture store opening in a parking lot. They've got a big light out there. It's rotating. It's trying to get you to come and drive in your car, and you look up and you see it shining on the underside of the clouds, right? It's big and circle. Okay. Now, this is a spiral. Look at this three-dimensionally. It's diagonal lines, right? But if you look at it three-dimensionally, it's actually a spiral. And this spiral is going back to the transmitter. And the storms are forming in this spiral shape. Watch. See that? As they're looking out, see the beam looking out at it? Right in there we can see in the beam. The beam is pulsing out and looking into the storm. Incoherent scatter and different types of ways that they look at the storm, using different pulses. And it's a corkscrew-like shape, another way to call it. A corkscrew shape. And the storms are forming in that corkscrew shape, going back to the transmitter at different altitudes. So we look at the echo tops and it'll tell us what altitudes these are forming at. Down here. So we're going up to 50,000. 50,000, 46,000. This is in feet. So, I mean, let's take it back. Watch. Starts with next to nothing. They hit it with the beam, and boom, it flares up to bright pink, which is the highest detection there. Goes out, or not the highest, but near highest, 59 to 60,000. So that's as high as they're targeting that beam. The beam's then creating storms that then follow back down at a lower altitude. See? We go then down at 30, and the green is down at 20, and the blue is down at 10 and 18. And it's going back towards the transmitter now, where, on the other side, spreading out along the field lines of the radars, this whole thing's rotating, we're doing the same thing. And it looks like it goes up to pink right at the 50. Yep, sure does. Right there. Right at the 50. And then you can see the spacing. It's undeniable. So can it modify the weather? I'm showing you real-time examples of it modifying the weather. You'd have to sit here and try and tell me all these are chance and coincidence. We can even go look at other stations in other parts of the country where, like up here in Idaho, for instance. Go look at Idaho. See what happens up there. Go look in Hawaii. Go look out at Puerto Rico. Go look down at Key West Naval Air Station. You'll see the same thing in different forms, but same thing. Check it out. Look. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Going back to the transits to Idaho now. And going up to the 50 nautical mile. It's our most recent. And it's back here as well. But we'll just take this in from the beginning and just look. Okay. Start of this whole thing. Look down to the east-southeast. Notice the spacing. 1, 2, 3, 4, 5. Going back to the transmitter, curling back. Okay. Then Same thing, same location even, southeast side, spreading out where the beam's propagating, and we get the, look at that. 1, 2, 3, 4, 5, 6, 7, 8. It's curling back to the transmitter at the center. Wow. Okay, that's storm total's got to be at least a quarter of a half inch on that. It's happening down at the beyond the 100 nautical mile range. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's happening in towards the 50 nautical mile range. Let's watch that. Oh, vaporized at the 50. Poof. Okay, now here we go. So we can only see it when it comes into view at the 100 nautical mile range. That's what they're choosing to show us. They could show us 200, 300. It goes out, like I said, 300. All right, so comes in from the west and right here. Perfect. Taking the field lines of the radar. 1, 2, 3, 4. 1, 2, 3, 4. Even taking the curvature out beyond. Wow. This is Idaho. And it starts to rotate at the 100 right there. It starts to rotate up. Do you see it starting to take a hook-like shape, the whole storm system? When it comes into the 100 nautical mile range, that's where they can spin it up, and it's starting to. On the north side, 1, 2, 3, 4, 5, 6, 7. Right back to the transmitter. I'm just proving it to you. It can happen anywhere. Let's go out to Hawaii, see what's going on out there. Do they have any storms even? Let's go to Oahu. Or, wait, why does it say Mauna Loa? Why is that called Mauna Loa? That's weird. Okay, what happened throughout the day in Hawaii? Maybe nothing. Might not a clear day in Hawaii. Okay, hey, here's them see up on the northwest side? I'm going to move this back and forth and look at it three-dimensionally. A beam rotating. Hold on. See the spiral nature in here? The curve, it's like diagonal lines. Okay, so that's shooting up out at the 100 nautical mile range. They're looking out at something beyond there, way up out there. Nothing the whole day in Hawaii, except for them looking at something, and it's exciting enough to produce a return off the cloud, just like scuffing your feet across the carpet, producing a little bit of a reflection that comes back to the radar itself. Let's go see what they're looking at up to the west, northwest. What's going on up here? They might not be looking at anything that we would know about. Might be looking up a little bit beyond normal radar view. You know, the military uses these, right? Okay, well, we've got the... Oh, wow, look at that. What's going on at the 50 nautical mile range there? That's just some weird... I don't even want to get into that. But then it takes the shape of the 50 nautical mile range. What is... Look at... Ah, God. Okay, so... Yeah, it's pretty obvious. Okay, so this one is pretty cool. I've never seen this actually happen, so I'll give you a play-by-play. We've got a bunch of ripples that form over the 50, and they're equidistantly spaced. But people just say those are clouds or whatever. But then look what forms. A front forms along the curvature of the 50 nautical mile range from there. It's on a clear day. And then it scatters. And then right here, this is the beam from the south that was lighting up that we saw to the south. There it is. It's showing up on the other radar. The other radar is picking it up right there. That's the beam from the south swiping it. Okay, and it's causing an excitement at the 50 nautical mile range, way up high. It's picking it up as a slight return. And then look what happens. As it's beaming across, look what forms. New clouds. It's amazing. Oh, wow, it lights it up pretty good, and they form, and then they go out of view. This is just cloud formation now, guys. There's no storms going on here. It's literally they're zapping up clouds in Hawaii. But you can see it on radar. That's how dense the clouds are. Let's go down in South Hawaii, the Big Island. Looks like a pretty clear day across Hawaii overall. Still, you can see it, though. Okay, now this is basically giving us half of a view. The mountain is blocking out the other side, so... This radar, you're only going to see half. That's why they have two radars on here, one on one side, one on the other. So that's a kind of a blockage from the mountains there. Okay, they're doing all kinds of looking down to the south. They light her up. Wow. Okay, so you'll normally only see this in echo tops, but this is actual precipitation. So this is like on a clear day, but this is above the transmitter. Do you see the rings? How they go back to the transmitter? I'm going to move this back and forth. Watch this. See that? That's the same shape I was showing you out at the edges where the storms are forming. See that? You're not supposed to normally see this on the... Okay. So, the green is actual showing us a little bit of precipitation, isn't it? Let's go look what the 1 hour storm total shows. What? Missing data. Have you guys ever seen this? You ever... What? What is going on here? Have you guys ever seen a bright red screen on College DuPage missing data? Let's look at storm total. Hold on. No storm total info. Let's look at hydrometer classification day. Is that... Do they have that? Jeez, you gotta be kidding me, man. Blocking the storm totals now. You gotta be shitting me. Pardon my language. Whoa! Dude! You kidding me? How you like those apples, guys? Look, there's going to be some times where I show stuff that I'm not, look. Yeah. Oh, radar can't modify the weather, Dutch. Do you see that? Okay, let me show you, in case you don't know what we're looking at. We're looking at the hydrometer classification. What the radar is, what it's classifying it as. So on the right, we got a key. And some of the things on here, I'll give you the HR, heavy rain. RA, rain. Right? Okay. HA, hail, gropule, and so forth. So if you see bright green light up on here, you know it's rain. And not just a little bit. It's actually a fair amount returned. But guess what? I wanted to go check that storm total, and we ain't got it. Unfortunately, it's not showing. I wonder why. Like the sound effects? Pew! Womp, 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 womp. Okay. Wow. Well, real time. Let's go back and look at the regular radar now. There they are painting it. And there's our precipitation forming really quick. The green. Hold on. We got some green forming as they're scuffing their radar beams across the carpet of the atmosphere, creating. This is shooting up, 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 and we're looking down on it like looking down on a spotlight, shooting up at an angle, basically. And, yeah, we get a little storm total precipitation on that. I'd like to see the storm total, guys, but unfortunately we can't. So. Not capable of showing that to you. I wonder what's going to show at Waimea. Waimea. Never mind. Let's go see. Dude, they're doing the same thing from the radar on the north. Watch this. It's going to show the same thing. Jeez. Wow. You can see the diagonal scan lines of the radar and the precipitation. Light but still, there it is. It's actually... Wow. Okay, let's go look at this. Do they have 1 hour... Oh, it's blocked there. How could they have the same... Guys, how could they have two different radar stations with the same problem? Uh-oh. You know, I don't like that. That has a sign of somebody hiding something. If I was doing this, imagine this. Imagine if I was in charge of the radar. And you guys want to check. You start go looking at the weather mod, and you think I'm doing some weird shit. And you go to check, and all of a sudden it's like, nope. Wouldn't you think I was doing something weird? Even if I was. Oh, look at that. So hydrometer classification shows it. More rain. Pew, pew, pew. Along the field lines of the radar. Let's go back and look at it real close. This is just showing here. When I'm talking about the field lines of the radar and the lines, the spoke-like shape that goes back to the transmitter, you can see it out there in the grapule. Or wait, what is that? Just dust or whatever. But, whoa, hold on. What's that coming off the... What's that bright green coming off the northwest side of the Big Island? Where did that come from? That's rain. They zapped it up, but where did it come from? Right in there, it looks like they zap it up. Somewhere right in here. There. But it looks like something coming off of northwest Hawaii. Anyway, all right. Enough is enough. Showing you guys this. I was only going to get on for a few minutes, but you can tell it's a topic that really interests me. And with people that are, they're like, oh, it can't be done, and denial and that kind of shit. You're not going to convince me. You might try and convince some viewers to dissuade them from watching or whatever, but that's just damage control. You'll never be able to convince me that this isn't being influenced by the radar. High power microwave systems, come on. You'd think you have to be an idiot to think it's not modifying the weather, actually, quite frankly. I mean, jeez, let's go in and look at a close level at Kansas and Missouri. Hold on. Let's get a regional view of Kansas and Missouri. Okay, one more time. Let's look at the radar live. So here they are, all kinds of beam shenanigans. Oh, perfect. Look at Texas. When I'm talking about the spiral nature of the beam and looking at it three-dimensionally. Hold on, we got to go look at Texas first. Jeez. This is just turning into just a train wreck of an update, but just got to show this to you so you can see what I'm talking about. Right there. See the diagonal lines on those? That's a spiral. See that? So you're looking at the center of the beam, the spiral shape. But you can see it goes out and around. It's like a giant cone going back to the transmitter, right? You see that. And then the other beam is different. That's called an incoherent scatter beam. And they've got that incoherent scatter beam going from the same station that's doing the other type. And then they cross the incoherent scatter beams up at an angle like two spotlights crossing the 20th Century Fox, crossing the spotlights. So this is crossed beams of incoherent scatter, and then another way that they're looking. This is all happening from the same transmitters. So when we see that shape, this shape, when we see actual storms form in this shape, going back to the transmitter, that's not a radar glitch or an echo, that we actually have storm totals that match the shape. That's not normal. That's not supposed to happen. And that's radar modifying the weather, either intentionally or unintentionally. And I would say they know what's going on at this point because they've been made aware. There's no doubt about that there's been no shortage of talk about what is going on. So they are aware. And if it is unintentional, then it's the most crazy unintentional thing you could ever imagine, because our storms are forming in those lines going around it, following back to the transmitters. It would be the perfect weather control. Hello. And check it out. I mean, now that you know what to look for, you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. See how they're taking the hook-like shape, each one? Each one, it's like a sawtooth, a reverse sawtooth. Do you see that? Yeah, that's not normal. And each one of those has rotation on it. Actual wind rotation. Let's go look at the wind. Wind profile should show a bunch of little squiggly lines up there where the wind's frickin' rotating around each hook. And each hook is like a edge of a saw blade that's going around and going back to... Look at the wind, guys. Come on, man. It's going in the spoke lines, going back to the transmitter. 40 miles, dead zone, green miles. 40 in the other. 40 knots. Wind. They're not hiding this stuff anymore. It used to be, Ducthsense, but I can show you real-time examples now, and nobody's going to convince me I'm wrong on this. Here's St. Louis again. Let's go look at St. Louis one more time. It did the same thing here. Oh, look, we have new storms forming right now out at the 100 nautical mile range. And I'll be darned, look. Each one forming along the field lines of the scan of the radar. So as the radar is scanning through, it's creating those. 1, 2, 3, 4, 5 going in a line back to the radar curved. Same with all the others down to the south. So NEXRAD is modifying the weather. It'll explain why we've had crazy weather since the 1980s when they installed these things. Wichita, Kansas. Let's go back and look at Kansas. Look at that. Look at that at the 50 nautical mile range. It's doing the same damn thing. Let's go to Colorado. Pueblo, Colorado. Let's go see what's going on there. I'll be darned. It's doing the same thing. So we'll zoom in and see. You're going to have the equidistant spacing on the storms going back to the transmitter, but let's watch it form. 200 images. I know it's mind-blowing. There's going to be a lot of people that are still in denial, but, I mean, again, is it possible? National Weather Service says electromagnetic radiation can modify the weather. That settles it. So is it possible? Yes. Did they know? I think so, personally. But so up to the north, crazy storm. Look at that. Crazy storms. 1, 2, 3, 4, 5. Going back to the 50 nautical mile range. Wow. As soon as it penetrates the 50, hold on. Right here, it explodes. It goes into across. This is going across the 100. Yep. Or the 50. It's going across the 50. And that's where we are currently. Let's watch it all again. Comes in, hits the 50. Look at what happens when it hits the 50. It explodes. Like it hit a force field. Doosh, doosh. Oh, wait. We get a right there. We get a scan from the radar coming around. Look at that. I mean, it becomes visible. So I would say there's more, maybe they're applying more power at that point, or for whatever reason, they're getting a reflection back, and it's showing up as its own reflection of itself. Anyway, you see it there, right? 1, 2, how many are there? 1, 2, 3, 4, 5. 5 in the pulse. That explains why we're getting 5 storms out on the other direction. 5 in the pulse to the west, 5 in the pulse to the right. Why is it 5? I don't know. I have no clue. Let's go up to Goodland, Kansas, where I got stuck for 3 days in a storm that was stuck there for 3 days. My wife and I got stuck on the side of a highway right outside of Goodland, Kansas, at Colby, Kansas. At the 50 nautical mile range from this, right over here, is a place called Colby, Kansas. We got stuck right here for 3 days as a blizzard parked right over there for 3 days, 70-mile-an-hour winds for 3 days straight. They had to call out the National Guard. People were stuck in their cars. We were one of those people. They had forecast light snow. That was it. And instead, a huge 3-day-long blizzard hit, stuck over the 50 nautical mile range. That was 2007. Okay, so what's going on now in Kansas? Let's watch. First of all, they're looking at it. You can see them looking at it before it even gets there with all the beams going into it up here. All kinds of weird little pulses and so forth that you'll see. Watch. You see that? Now, this right here is an echo. So the radar, high-power microwave, shooting up, spreading out in a vortex. Again, this is a corkscrew, not just diagonal lines. And it goes and looks at the storm, and it reflects back. And that's an echo of the storm because they hit it with a high-power pulse to look at it, look through it most likely, looking through it to the other side maybe. Anyway, it reflects back. So that's not storm formation. But then storms will form along those lines in that same shape. Watch. Right through the center of the storm. Let's take it back and show you one more time. Watch. 1, 2, 3, 4, 5, 6, 7. Going back into the center of the storm, leading it out here and here, connecting between them now. The beam, forming storms connecting between. You can see them just zapping the shit out of the storm as they're looking at it with different types, different ways to look at it to get different resolutions and penetrate to different parts of the storm. But as they're doing that, that's creating new storm formation along those lines. So, zap out in front of the storm here, for instance. Looking at the storm in front of it, right at the front end of the storm, a new field line forms, and storms form along that, and then they start scanning the low beam, and it hits off the wind farms here. These are all wind farms that are being hit, reflecting back. So at low tilt, we'll bring it in and touch the tops of the wind farms. We could talk about what causes reflection from wind farms aside from the windmills themselves. Anyway, this thing goes right across the center, boom, picks up rotation, goes out the other side. And this takes us up to current, where we have storms forming equidistantly spaced along the field lines of the radar back to the transmitter. 1 hour storm total, let's go see it. At least they got it. Goodland, Kansas has the 1 hour and total storm totals. Let's go look at the actual precipitation that fell and see if it matches along those lines. Okay, first, right off the bat, yes. Yes. Okay. So, what are we looking for? We're looking for the scan lines of the radar in the storm totals. And you can see it. 1, 2, 3, 4, 5, 6. And then a open area. Perfectly open area. Flat. Where the beam is clearly parked, looking at the other storms, and then it does it on the south side. Same thing. 1, 2, 3, 4, 5. Going out in field lines along the radar. Tisk, tisk. How about that? 1, 2, 3, 4, 5. And what's the storm total? 2 inches. 2 inches at the center of each storm that formed on the edge of the field lines of the radar as it scanned. 2 inches now. 1, 2, 3, 4, 5. Perfectly spaced. And you can even see the block-like nature of the edge of the spokes of the radar. This is out to the perimeter of what they're showing us, out beyond 100 nautical miles. You can see it on this side, too. Okay. Enough. Enough is enough. You've seen enough. Enough talk about the weather. I said we weren't going to do that. I'm really into it. Well, everybody said I was faking this stuff. That's where we first started. Faking. I was faking. And on that note, we should go look at the USGS website. I'm going to go get some food, actually. Not going to eat fake food, though, man. I'm going to go get some real food, and I'll be back. Enjoy the silence and the ding of the bell with the earthquakes, then we'll come back and listen to some more music.